All right, so if we're going to graph logarithms, the best way, you know how to graph exponentials already, right? Okay, the best way is to rewrite it as an exponential and work backwards. Okay, so we're going to rewrite it as an exponential. What is it? 2 to the y equals x plus 1, or sorry, minus 1. So we just rewrote it with the definition of a log versus an exponent. Now, the key here is to use these numbers in your y values. Makes it, because that's in the exponent, it just makes it easier. 2 to the y equals x minus 1. So if we're going to do -2, we'll have 2 to the -2 equals x minus 1. Right here. It's my y value. Put it in the y value spot. So, what's the answer? Yeah.
You add 1 to everything?
Yeah. That's 1.5.
Two, 3, 5.
Now, let's graph it as normal. Think you can handle that one? The twist is there, use your y values. Because the y is in the exponent, it makes it easier. Okay, maybe tell me what the vertical asymptote is? Yep. What's the equation? X equals 1. Okay, notice your families of functions apply here. That one tells us to move it right 1, correct? So it's just shifted 1 to the right. Log base 2x comes right to the y-axis. This one shifts 2 to the right. So you can still use that. If I said plus 3 out here, what would happen? Up 3, right. Okay. Okay, properties. We're going to just compare and contrast this to the properties of powers. Give you something to reference. So you remember what that one is? What do I do with the m and the n? Add. Yeah, okay. Okay, we have a similar one for logarithms. M times n inside, you can split it and add them as two separate logs. You can also go backwards. Most of the time we use this going right to left to make things more simple. Here's the next one. Yep. So we can write a similar rule for logs here. We subtract them. So those two directly compare to each other. Kind of nice that it works out that way. You good? Got a one yes. Okay. And the last one's kind of screwy. It doesn't match up with anything, and it's kind of like, why do they do that? But you just kind of have to accept it. Okay. It's a log with a power on it. So log base b m, and the m has an exponent. Okay, this is the power rule for logs. You can move it out front and multiply. What? I know it doesn't look like it should be like that, but that's just the fact of the matter. I mean, we could derive it if you want, but I don't think we need to worry about it. Just remember that rule because it's very useful. Okay, very useful solving equations. So we're going to use these solving equations with the definition of logs. So let's look at So I'm just going to go through and show you a variety of ways to solve for different variables in logarithms. Again, no way I'm going to be able to show you every situation. So we're going to use the properties and the definition of a log to solve. So log base b, 15,625 to the 1/6 equals negative 1/3. Here's our variable, right? Okay. If the variable's in the base, best to rewrite it as an exponential. Okay. Does anybody know what that number is? It is? Yeah. Nice. rewrite this. Because it's a negative exponent. Well, we're going to get rid of that. Yeah. And it's 1/3 power, so it's a cube root. Either way, it doesn't matter how you write it. But how do we get that out of the denominator? Yeah, you multiply. So we get 1 equals 5 cube root of b. So 1/5. And how do we finish it? Yep. You said it. So b equals 1/125. Right. High quality. Can I move on? Not yet. Okay. I will wait.
Where did the negative go?
What negative?
Oh, that's like.
Okay. All right, here's the next. So I'm going to show you two more. Solve. Log 10, 2x plus 5 equals log base 10, 5x minus 4. I didn't show you this property, but do you have any idea? Yeah, the log 10s can go away. So 2x plus 5 equals 5x minus 4. X is? Okay. All right, one more. This one will show you a little bit more of how to use the properties of powers. So log base 3, 4x plus 5 minus log base 3, 3 minus 2x equals 2. There are a couple ways to do this one. No. Okay. So first thought sometimes is to move this over and add it, right? Is there any property that 2 plus log something helps us simplify? No. Can I simplify this side though?
Yeah.
What is it?
Log base 3 times 4x plus 5 divided by 2. Why do you divide it?
It's the subtraction property.
Now what can we do? Can we rewrite it as an exponential? Would that help?
No.
I think it would. Because it'd be 3 squared equals 4x plus 5 over 3 minus 2x. Right? Yeah, I think this is the way we need to go. I don't see any other way to do it.
You don't do this before.
No, I don't.
He learned it.
Do you know why?
Because otherwise you would just write everything down and make us copy it. Before.
Because you
No.
like that.
No. I do it so you guys can see how I solve problems. As somebody that's mastered math, it's good for you to see that model. So I don't do these ahead of time. I don't do the warm-ups ahead of time. So you can see if I'm doing it, how I think through it at the same time. Now I cheat a little bit more than that in calculus. Sometimes I work through them, but a lot of times I don't. Sometimes I get stuck in that class. We have left several problems unfinished this year because I've been stuck, so. Okay, so we can do what with that?
You have to multiply.
Yeah, there you go. Just multiply it out. Don't make it complicated.
You can say that to 9 and then have to do it.
Yeah, that's a 9, right? And then distribute it. You can solve that, right? Is that something?
I got some weird.
Yeah, me too.
You get 16 over 11.
You got 1?
Yeah.
Oh, yep, that's it. Because I added and subtracted wrong. There you go. You might run into a quadratic. If you do, the video from second hour actually has one on it that's a quadratic. And the book has an example in it that's a quadratic. Okay, so be aware of that. But yeah, the rest of the time is yours to work. I will write the homework down again. It's due tomorrow.
Pick one. Yeah.